So my name is Ignacio Johannesen. I'm a postdoc at DTU Wind. So the presentation was about the new experimental campaign of FloatLab, and I presented the results, or preliminary results of the wave-only test. So this campaign involves a very complex system that we have a floating substructure with a turbine on top. So we have a floating turbine system with wind generator and wave generation. So the preliminary results basically show that we can excite the natural frequencies of the tower with fourth order kinematic forcing on the platform. What you want normally at lab scale is to have it as big as possible, as the lab allows you, right? So right now, for example, what we are testing in FloatLab is maybe not bounded by the substructure, but it's more bounded on the size of the turbine. Right now we have a 4-meter diameter turbine, which is very big to handle. And that is right now also bounded by the size of this new wind generator that we are testing. So the turbine cannot be bigger, but hypothetically, and we have tested it before, we can make a substructure that is bigger on the wave basin, but also it has its limitations. We need to de-risk the technology. I think that there are a lot of things in the technology that are not fully understood, but this kind of project like FloatLab basically help to de-risk the technology by understanding what happens in reality or in these very complex situations in the lab, and both in the lab and force models and complex simulation process that we can carry out. I would say that there are many different key challenges, but specifically the ones that we are working on right now, or the ones that I try to present, is that this kind of complex system, they behave very differently with different order on the solution and on the forcing part. So we are focusing on high order forcing and motion, the response of this platform basically. So it's complex to model and to understand.